Usually you get one guy in here that's doing it for a living and he never got his degree and he just needs to he'd never get promoted to manager until he gets through the class. So he's telling me all this JavaScript stuff because there's people around here that freaking know a lot about JavaScript because they work with it every day. I don't. I mean, this is maybe 1/6 of the languages that I teach in a semester. I'm teaching a lot of different languages. But closure is one of the hardest things to conceptualize, and so I think it's worth taking some time to think about this. Maybe we'll even close on this topic. I wonder if there's any more topics after this. Recursion. That's too much work. We'll start with recursion next time. But let's think about closure. In JavaScript, we talk a lot about closures. Now, what's just a closure? It's basically the ability to have a method function that runs, and even though it's over, the function's gone and it's no longer running anymore, you can still have values hanging around out there that you can update. Classic one is you have some counter hanging out there and you run the function and it updates the counter, and you run the function and it updates the counter. But the function's now gone, it's not running anymore, but that value is still hanging out there. It's a JavaScript thing. The concept of closure is in other languages too. But let's take a look at what's going on here. Here we've got a function called wrap value. And it declares a local variable, and then it returns this function, and the function is a function that says return the local variable. Now, how do you suppose, what's going to happen if I run that function? This is for the overachievers in the crowd. If you can sit down in a class and you can understand the concept of a closure the first time you hear it, man, my hat's off to you, because I sure couldn't.
So can I create a function? Like actually write a function that will return a local variable? Is that what it's doing?
I think you're onto it, but so here, I mean, we have a function and it has a name. The function is named wrap value. We've declared this function, we've defined the function, right? We know what the function does. If I run wrap value, and you can see the line, wrap 1 gets wrap value of 1, wrap 2 gets wrap value of 2, console log wrap 1 and wrap 2. So when I run the function and assign the output to a variable, what's in that variable? In other words, what is the output of wrap value? 1, 2, function? What is it? You would think, right? Let's just take this now. This is something that you can do too. You don't have to necessarily open up a text editor. You can just take this code and you can copy it, and you can go into your console and you can just hit enter. Now wrap value exists now in my console environment. So I can type wrap value of 1. What did it return? A function.
So it's defining a new function based on the value you give wrap.
It's not defining one, it's returning one.
A new function.
But what's the name of that function? What's the name of the function that it's returning? You're onto it. It doesn't have a name. This is an anonymous function. And you use anonymous functions in JavaScript all the time. And if you're not used to them, it's like, what the freaking hell are they trying to tell me? Why are they doing that? Why not just output a number? You know, it's like you think about juggling, right? It's hard enough to juggle. But once I can juggle balls, I can juggle knives, I can juggle torches, I can juggle everything. But now I'm juggling jugglers. Right? That's what's happening. I'm a function, and I'm passing function. You can pass functions to a function, and you can return functions from a function. Those functions might even take functions as parameters and return functions as output. So it's really hard. That's why I say functions are where the action is in JavaScript.
What's the advantage
for just calling functions and getting the code values.
Now that's where fistfights start breaking out. I mean, I don't want to start giving you any kind of opinions because you get somebody in here and they're going to take me out to the parking lot and teach me a lesson. I mean, what's the advantage of it? You know, I'm just going to tell you that's how JavaScript is. It enables you to do certain things. It also confounds people. But the advantage of it is, of course, that you can play with your function. You don't have to have it predefined. On the fly, and this is really the world of the web. You don't know what objects you're going to be dealing with. You don't know what the world's going to be like. Even if I write the program today, I might know darn well that the data structures are going to change tomorrow, or even the functions are going to change tomorrow. Whatever function it is, just pass it in. We'll run it. Right? We're basically writing programs even though we don't know what the world's going to look like tomorrow. Now, of course, those programs are going to totally blow up. But why didn't they write it this way? Well, we didn't know, and we wanted to get it done. We wanted, so now people who are kind of freewheeling and loose, they're like, you're worried too much. Let's just write the function. But the people are like, no, we're building spacecraft or we're building a pacemaker. I don't want to do it this way. This would not be a good style for air traffic control, maybe, right? Because there's too many. You want to lock things down and nail them into a box. But in the web, it's like, who knows what they're going to want. So just whatever function, they pass us that function and we'll process it as best we can. And if there's a whole bunch of errors, we'll just ignore them and proceed along as if everything's fine. That's programming in the web. That's why people, I've had arguments about this, but I'm not going to get into it. Okay, so the closure is this I guess, persistent entity that exists even though the function has been run and done. The function doesn't exist anymore. There is no variable, but there is a variable out there. It's been created, but the function is come and gone, and it's now vapor. So, what do you think is going to happen with? Well, it says right here, right? We have wrap value 1, wrap value 2. The variable can still be accessed. So a lot of times they'll call this a closure. They'll say, hey, we want to, I think it's still going to record okay on Echo 360, so you can still see this. But this is a closure. This is an example of a closure. So you can reference a specific instance of a local variable in an enclosing function. You can access this instance of it. Yeah, so here we go. We're creating a function that can multiply an arbitrary amount of numbers. Yeah. So here they say think about like freezing your code. So what I would do is, maybe we will continue to go through recursion. There's some good exercises for this chapter. Kind of play around with closures. Even look up closure, and if you can stand next to your buddy who's a programmer and say, hey, I'm going to tell you what a closure is, and you tell him what it is, you're doing better than me, because it's hard to explain in words what a closure is. Maybe you can go on YouTube. I've heard Doug Crawford, the guy that is famous for this language, and it's hard to understand what he says. Anyway, okay, moving right along. But you guys see what's happening here, though. That's the main thing. This thing is returning a function, and the value, local variable, can still be accessed. Can anybody explain that to me? What is wrap 1? What is wrap 1? Is it? Well, yeah. I mean, I guess everything is in JavaScript, right? So let's just go back. Huh?
In console, it's treating wrap 1 as a function.
Wrap 1 is a function. I mean, yes. So, but since wrap value returns a function, it's assigning the output of wrap value, which is a function, to wrap 1. So now wrap 1 is a function. So basically, we could say this. Wrap value is a function that returns a function. Wrap 1 is a function that returns a value. Sorry, wrap 1. You see that? Let me just do this again. That's still there. So let's just do this one more time because I want to make sure that I don't want to skip over this. Can we agree that wrap value is a function that returns a function? Can we agree to that?
Yes.
Okay. Now, if I go here and I take wrap 1 is going to be a variable, what we're going to call it, and it's being assigned the output of wrap value when 1 is passed to it. Okay? So now I'm going to go back into this code and I'm going to say wrap.
So it's becoming a function because a function is assigned to it.
Yep, exactly. And now if I want, and so if I say, so wrap 1 is a function, but if I say wrap 1, so wrap 1 is a function, therefore I can put parentheses around it, right? So I can do this, right? I can execute that function, and now it's going to give me the value 1. Why? Because that's the value that was assigned to it when I used wrap value to declare it. So now I kind of create the framework of a function, and I can put as many numbers in there as I want, and I can have as many functions as I want with those different numbers. Now you can imagine the power of this, right? Suppose that the function was not wrap value. Suppose the function was state is coastal, and it would tell you if the state was coastal or not. I mean, United States state. Alaska, yes, coastal. Iowa, no, not so much. So you can have all kinds of code in there. You pass it a parameter, and now it's got the whole function that goes along with that particular parameter that you put in there. You've created a whole new function, right? So you've got a family of functions. You can kind of think of a closure like a family of functions. How about that? Pretty wild, right? Not something that you find in every day. So, what we're saying here is this local variable is still out there. You know? But if you did another function with a different value, it would be a different value. Okay, I think we've beaten that horse enough. Let's take a look at recursion, because I think that one might be easy enough to grasp. Did you guys do recursion in 116? We didn't do it in 116, did we?
216.
216?
We did that a lot.
You did a lot. Okay, good. Okay. Yeah, the classic joke about it is you go into a dictionary and you look up the word recursion, and it says look up, see recursion. And I mean, the idea is the program calls itself, and so the chicken and egg would be kind of like a recursive thing. The chicken's calling egg, and the egg's calling chicken, so it's eventually recursing. The most important thing to remember about recursion is you have to have a way for it to end. Same as a loop, right? You can have infinite recursion and infinite loops. And so this particular program here is recursively determining the power of a number to a certain power. But if the exponent ends up being 0, it just returns 1, and it keeps on decrementing the exponent by 1. So even if you had 1,000,000, eventually it's going to get down to 1. But you have 1,000,000, I guess, layers of the onion that you have to go through. So, should I go through the anatomy of this little function? Yeah, let's take a look at it then. So here we have a function called power. Now, what this function does is it takes base. Let's say it's 10 to the 5th, okay? And so if I have base is 10 and exponent is 5, if I go into the if statement, we'll just go around the room. How about, I don't know, you want to start us off in the middle? Let's go that way. If I have base is 10 and exponent is 5, what happens on line 2 right here? Oops, right there. If exponent equals 0, is that going to fire? If base is 10, exponent is 5. Yeah, what's that?
It will after the exponent hits 0.
Right, but right now it's not going to, right? Because right now base is what the hell? I just wrote up there. Base is 5 and 10 is 10 and the exponent is 0. So if exponent equals 0, it's not 0. Exponent's 5. So we're not going to return 1. I don't know how I could lose my pen that fast. Just wrote that. So then, how about it? And the else, what's going to happen?
So now it's going to do the base times power, and then the exponent's going to get down to 4 now.
Right, it's going to return base, which is 10, but then it's going to go times power. Oh, I've got to call power again. Well, wait a second. How can power call itself? Well, it can. So now it's decrementing the exponent by 1. So now we basically set that whole thing aside, and now we're just into this little guy here. So now base is 10, exponent is 4. Right, exactly. So now what happens? Cecilia. Now we're into this little section of code. Base is now 10, exponent is now 4. Then what's going to happen? Is it going to do that one? No, so we can forget that. It's going to do this. Then it's going to return base. What's base? Still 10. And what's this going to be? Man, I wish I had my pen. How can I write this and the thing's gone? It's my pocket. That's fine. I don't know what the hell I'm doing. All right. Whew. Losing my brain. So the first layer, the base, is 10, and the exponent is 5. But it suspends everything, and now the base is 10, and the exponent is 4. Right? So it kind of has to wait again, right? Because we can't go any further. We have to evaluate this power. So now, Dakota, yeah, I want to say Dakota. Yeah, Dakota. So now what's the situation?
It's going to check to see if the exponent's 0, which it isn't.
Right. Now base is 10 and exponent is 3. And we got to do that again. Keep on going. 2. And then eventually it's going to get down. So now it's 2. So now it's 1. So now what's going to happen?
It's going to call it one last time, and then it'll return 1 at the end.
Oh, it's going to go one more time, right. So now it goes down to 0. Sorry. Goes down to 0. And then,
Return 1.
so then it's going to return 1. And then it's going, so that's going to be, so that returns 1 up to this one, right? And this is going to be 10 times 1. This is going to return 10 times 1, right? So this is going to return 10 to this one. This one's going to return 10 to this one, and so on, right? And so this one should return 10 to the outside world. 1, 2, 3, 4, 5. Boom. 10 to the 5th is, in fact, a 1 with 5 zeros at the end of it. That's recursion. In case you didn't already know. So, I don't know. We can dig more deeply into this, but I'll let you guys go ahead and tackle the rest of this. This is longer than I thought. Oh, okay. So, I mean, recursion, we can go into it as deeply as you want, but I think that explanation is fine. Let's just wrap things up with the last comment. And you will hear this a lot in other languages, but you really hear it a lot in JavaScript. You're going to have, in any given function, you're going to have a return value or a side effect. And I don't mean a side effect like, collateral damage or something like that, but it is kind of. So console log would be a side effect. Possibly a print statement might be a side effect. Whereas a return value would be something like this number, 10,000 or 100,000, what is it, 10,000? I guess it said, no, 100,000, sorry. 10 to the 5th. So this right here would be a return value. But if I put console log 100,000, that'd be a side effect. That's it. And of course, methods and functions can have both return values and side effects. Sometimes it's conceivable they might have neither, but usually they'll have one or the other. So, I mean, we are going to get a lot deeper into a lot more different kinds of functions. If you want to get ahead and you get some of these questions, they get weirder. We've only scratched the surface of JavaScript, but if you want to try tackling it, I strongly recommend you read the book, then come to class and ask questions and wonder what the hell's going on, and then leave and read the book again possibly, or watch videos or whatever you want to do, because it's going to be complicated. But by the time you finish this course, you're going to know JavaScript. So I think that's enough mental energy for one day. We didn't really get a good break today. So any questions about any of this stuff? All right, we tackle chapter 4 when we come back on Wednesday.